Okay. All right. So I said I'd start off with the whiteboard because I feel like this is the best way to incrementally develop the concepts that we're trying to get to. Now, as I do this, I'm going to start very basic and simplistic, and I'll check in with you and see whether or not I'm moving too slowly or it's right or not fast enough or what, but you can let me know. So the first thing we're going to do is I'm going to draw a workstation. And whenever I draw my workstations, I generally draw them, actually I draw servers or workstations about like this. A workstation I normally actually do sort of like this. But okay, so that would be a workstation. And I'm going to I'm going to have this, what I'm about ready to draw here. We'll assume this is a printer, okay? So we've got a little printer there. We've got a workstation. And we have a direct connection from our workstation to the printer, okay? So at this point, we actually have a network. A network consists of two or more devices communicating with each other, either connected physically or wirelessly, but we now have a network. And so let's say that what I had up here, and in this environment is, let's go down here, put some text. Let's say what I had that was ready to go, we'll put it right here. Let's say I had some data that I wanted to print, okay? So pretty easy. If I want to print that data, what I've got to do is be able to move that data out that to the printer. Now that's very straightforward. However, what we would want to have before we would just send the data, we'd want to also have some instructions. And so let me see, I'm having trouble. I want to actually move this, can I? Yeah, let's see if it'll let me do that. Okay, and then I'll do that. Okay, so I have my data here. Getting sort of familiar with this thing. Format styles. Oh boy, this is font size. Okay, well, then we want to go to about 10. Okay, so I've got my data. And what I want to do is I want to send that data to the printer. Well, if the printer just gets data in without instructions, what is it supposed to do with it? And the instructions could be involved in as far as, what kind of paper, what the orientation is, what type of font, and so forth, and whether it's in ASCII or some other type of coding. So what we would do if now we don't do this, but our computer will do this for us, is we would put on top of this data here, let's just do that again. We would add a little header, okay? So right about there. And inside that header would be some instructions, but we'll just call this the header for right now. Okay. Okay. So, 12, maybe go a little bit more just so we have, yeah. I know it's a little sloppy, but that's because of this, still getting used to how exactly this particular whiteboard works, but okay. But the idea is pretty simple. I'm going to have all of this is going to be sent across from this station to that station. The header will contain instructions as to what is supposed to happen when it arrives there. And the data is what will be actually printed. Okay, so all I'm really doing is introducing a basic concept that when you are sending data, that you have to send it along with instructions, and those instructions are in a header. Now, the format of the instructions in this header would be called a protocol. So what I would have is this header here is going to have some protocol, which is going to describe, I should say the protocol itself describes the format of the header. Okay, and when we get into this and more, we'll see that these headers are more involved. There's different parts to a header, but basically the protocol dictates what the format is of the header. And it's very simple, very simply like when you are going to mail a letter, what do you put first? You put the name of the company to which it's going. What do you put next? You put the street number and address, or street name and number. And then after that, city, state, and zip. So that is the protocol for addressing letters. And if you mix that up, your letter will not get delivered properly. Any questions about that? Okay. So I notice we've got things buzzing all over the screen here. Are you guys moving your mouse across the whiteboard? I've never used this before, so I don't know why that's really happening. But anyway, so yeah, at this point, I don't think I've enabled you guys to write anything on there. So yeah, if you could just keep your mouse quiet for now, that would probably help. Okay, so notice that or let's look at this. If I send something from here to here, do I have to have any address on the front of this in order for it to get from here to here? The answer is no. It's not a trick question. It's just simply this. This is a point-to-point connection, and that is a type of network or type of connection. We'll come across this in networking a lot, point-to-point. So that refers to this connection right here. It's point-to-point. If you send something out here, it's going to end up there. It does not need an address for this device to know that it is the recipient, the intended recipient. Okay? Just like when you're talking on the phone, if you don't have a conference call, you just have a phone connection, you don't have to say before every sentence the name of the person you're talking to. You just keep talking because you have a point-to-point connection. Okay? So that's what's going on here. Well, most networking that we're going to be concerned with is going to involve point to multi-point. So let's get some things off here. Let me see how I can erase things. Line, boy, how do I write? Let's see if I can do that with a little delete. Yeah, there we go. Boom. Delete. Okay. Delete that. All right. So that was a very simple network. And what we saw is that when we want to send data, the data is accompanied by a header. The format of the header will be determined by a protocol. The header will consist of instructions to the recipient, and across a point-to-point connection, we do not have to have any address. Now let's draw a little bit more complex situation here. And now what I'm going to do is I'm going to draw a server. So when I draw a device that looks like that, a rectangle that looks sort of like that, this would be a server. This will be a client or a workstation. That's going to be a server. And what I would have is some type of connection between them. Now, I'm not going to do a point-to-point because I could have another actual, let me see, is there a way to copy that? No. Paste? No, there's no paste. Okay. So I'll just have to build another one here. Here's another workstation. Okay, just put this here. So now I have two workstations. And what I'm going to do is I'm going to put them on a network. So here is the cable that's going across in this network. And each of these has a little connection to that cable. Okay, so far so good. We have a small network now, 2 workstations and a server. Stop me if anything I say isn't clear on this. But now if I want to communicate from here to the server, there's an issue, because when I send it out on this wire, I'm going to send it in both directions, send it out this way and that way. How is the server going to know when this comes along that in fact it's intended for the server? Well, the way it's going to know is because I'm going to include in the header some addressing. So now let's give each of these devices addresses. And what I'm going to give them is something called a MAC address. Okay, so I'm going to write over here, MAC address. Now, there's a lot of different names for this address that we're going to use. It's also sometimes called a physical address, and called a NIC address. It's been called a BIA, which stands for burned in address. It can be called an Ethernet address, and so on. Actually, I could go on and on. There's all sorts of different names. They all refer to the same thing in what we're going to be talking about is the address that is on the network card in here. So we're going to assume there's a little network card. And again, I could have drawn these a little bigger. I wonder if I can actually pull this out a little bit. Okay, that's a little bigger there, a little bigger there. Okay. Now, what we want to imagine is inside here, there's a little network card connected to the network. Okay. And let's do this, get this down there, and put another little network card. Okay. So all of these, we now have, what we have is a network interface card, or a NIC. Okay. And on the card, there will be burned in an address. That's why we call it also a burned in address. This is an Ethernet network, so we can call it an Ethernet address. This is at the media access control layer of a model. We'll see that model later. So it's sometimes called a MAC address. And because it is connected to the physical wire and the card is a physical element, we'll call it the physical address sometimes. So all of these are the same thing. And what we're going to do is we're going to use, for addressing on these cards, hexadecimal numbering, or a characters, hexadecimal characters. Now, how many of you are familiar with hex real well? Okay, anybody? Okay, so one hex character represents 4 bits binary. Okay, so let me show you how this works. Let me do this. So let's say I had in binary a 0, a 0, a 0, and a 0. So I had 4 binary zeros. What I would represent that with as a hex character is 0. That's not too hard to understand, right? Now, if I had 0, 0, 0, 1, then that would equal a 1. Well, why is that? Well, here's what's going on. we have each of these locations in this hex address, each of these 4 characters has a number value assigned to it. If it's a 1, it's 0 if there's no binary 1. So let me see if I can draw this out and make this make sense. Okay. Okay, so let's say I've got something like this. 0, I'm sorry, that's not, it's gonna be a little bit cumbersome. It's so much easier on a whiteboard, but okay. Okay, I'll get this out here. Okay, so 1 hex character is used to represent 4 bits in binary. If all 4 were zeros, it comes up to 0. But what we do is we assign a value to each of these places if it's a binary 1. So if there is, let me see if I can get this. If there's a binary 1 here, it's worth 1. Trying to get that to move up. There we go. Okay. If there's a binary 1 here, it's worth 2. If there's a binary 1 here, it's worth 4. And if there's a binary 1 here, it's worth 8. Okay. Let me see if I can get that form. Move that over just a little bit, just so it looks a little nicer. Oh boy, this thing's hard to grab. There we go. Okay. And then we have this over here. Pull that out. It's 8. Okay. All right. Is everybody with me so far? So I am going to represent a combination of 1s and 0s here by assigning the numerical value up here. If it's a binary 1, if it's a 0, it's worth 0. So we add this up, 0, 0, 0, 0 equals 0. 0, 0, 0, 1 equals 1. So 0 is 0, 0 plus 1 is 1. Let's go here. More text. Can I just go in there and click in there or not? Will it let me? No, it will not. Okay. So now I'm going to go here. What is 0, 0, 1, 0 equals what?
2.
2. Okay. We're going to keep going on this, okay? I know this is very simple, but this is basic. And actually, once you get this down, when we get into IP addressing, you'll be using an expanded version of this equals what?
3.
3. Whoop.
Four.
Okay.
I think everyone knows hex.
5.
Well, okay. I just want to, if everybody knows hex, let me just go a little bit further. Okay, we'll skip on. Everybody knows hex well enough, so I can just skip down, right? 1, 0, 1, 0 equals
10.
yes, but in hex we don't use 10, right?
Oh, A.
Equals A. All right. So we good so far? Any questions on hex then? All right, good. So now, what I can do, delete all that. Away we go. And go back here. Oh, come on. Move on. All right. All right, so now back here, I'm going to give these, I don't have room really to write in there, but I'm going to say that this station is, let me just do this up here. And I'm also laying out how I do things. This first station is going to be 0A. Got 0B. I'm just making these up, okay? And we've got 0C. All right. Now, a MAC address, I'll call it a MAC address for now, is 48 bits. How many bits have I represented here? 8, right? 8 bits. So I'm shortening this for our purposes. All right? But the MAC address would actually have 4 times 16, no, 3 times, 4 times 12, it would actually have 48 bits in it. Okay, I have 12 characters. Okay. Now, let's say I want to send some data from here to here. So now let's draw what that's going to look like. What I'm going to do is I'm going to send packet, and I'm going to put in some information. I'm building a header right now. Okay, right there. Okay, and now, okay, inside I'm going to be sending some data. There we go. Move that up a little bit. So here's the header up here. And in the header, I want to have destination address and source address. It's coming from 0A going to 0C. Okay. So destination address would be 0C. Source address going to be 0A. Okay. All right. Boy, that's not what I wanted to grab. Okay, you guys get it. So I've got this here going from 0A to 0C. Destination address, source address, data. So far, so good. Everybody okay with that?
Yeah.
Okay. Now, these two are fields within a header, and this is the data. So far, we're only representing 3 different components, really, of our whole environment here. We've got the physical represented. We've got the next layer up of addressing. And then we have the data, which is coming from up above. If I send this out on the wire here, Ethernet, when 0B gets it, 0B looks at the destination address and says, is that me? No, it throws it away. 0C gets it and says, is that me? Yes. Strips off the header and hands the data on up. Okay, that's the basic communication process. We're going to get more involved with that, but I'm trying to just lay this out for you. So in doing all this, what I've introduced you to is the concept of we have a packet, we have a header, we have fields within a header, we have a packet that's going to travel on a wire, and then the question is, how do we get it onto the wire, and what type of environment is this? Well, this is a multi-access environment, meaning that 0A could be sending at the same time that 0B would be sending. And if they're sending at the same time, there's going to be a collision. Okay? So in Ethernet, which is what this is, what we use is CSMA/CD. Okay. Is this familiar to everybody? First time for anybody? Everybody's good with CSMA/CD? What does it stand for? Carrier sense, multiple access, CD. This is the method used by Ethernet to control access to this wire. This is a contention environment, meaning that we are contending with each other to talk on this wire. What we do, if we are a driver right here driving this card, piece of software driving this card, the first thing we do is CS, carrier sense. We listen to the wire. We see whether there is a signal on the wire that indicates that somebody is transmitting. If there is no signal on the wire, then because it's a multiple access environment, we are allowed to go ahead and put our signal on the wire. And as we put our signal on the wire, we listen to see whether there's a collision. So if 0A put their signal or their packet on the wire at the same time that 0B did, because to both of them it was quiet, there would be a collision. And the way that they would detect the collision is by listening to the signal on the wire. And what they would hear is not only their signal that they put on the wire, but the other person's signal. And that increase in voltage would tell them there is a collision. What they would then do is back off a random amount of time and attempt to do it again. That is Ethernet. So far, so good. All right. Now, I'm going to pull up some slides and begin to, let me go into module 3, and we're going to start talking about protocols and models, and this will hopefully tie into this, and you'll see why I'm trying to lay this out. Okay. So what will happen in communication is we have to have protocols so that when we send something, we have the proper instructions in the header and in the proper format. And when the receiver gets it, they will understand how to read those instructions. There has to be a channel for that to go over, some type of path or media for it to go over. There are all sorts of different protocols out there. This is basically what I just showed you there. Okay. Some of the things that we have to agree on at different layers or levels, the encoding, formatting, size, timing, etc. So protocols will address these things. Not every protocol addresses all of these. Now, what we have done here is jumped, and this is what I don't like about this, we've jumped from the concept of protocols to the IP version 4 protocol. Actually, this is IP version 6, I'm sorry, IP version 6 protocol. And we're looking at the header for IP version 6. What we'll look at right now, just note, because we don't want to get too involved with this, is that this header has a lot of other things, but it also has a source IP address and a destination IP address. Okay. The total length of all this is 40 bytes. Okay. From top to bottom. That can't be right. That's not. No, that's not right. Okay, so disregard that. That to me is incorrect and confusing. I think what they're saying, this direction versus that direction. When you get all these together, it's actually much more than 40 bytes. Okay. All right. So when we're sending things across the network, we'll end up having to chop things up. So if we went back to my whiteboard, oh, I'm sorry. You know what? I didn't share my screen. Sorry. I've got to share my screen. Got to go back to here. Okay. There we go. All right. Let me back up here, because these are the slides I was going through. Source, sender, destination, just we talked about that, what we talked about there. These are some things that protocols address. This is the IP version 6 header. And one thing that will be determined by the protocol is the message size. What they're trying to imply here is that you can't just send something huge because of limitations that there are out there. So sometimes you have to send it in smaller packets. And some things that we have to do is control the flow. In other words, how much information goes across to the other side within a certain amount of time. How long do they wait if they don't hear a reply? And then the access method. So what we just saw was a contention access method. There are multiple access methods. Contention is one of them. And what we try and do is detect collisions. We're using collision detection, not collision prevention in this method that we just described. When we are sending, there are different types of addresses that we can use. And you'll need to know these. Unicast is 1 to 1. So what I just described in the whiteboard was one station communicating to another single station. When you have multicast, it's one to many. And usually it's a group. Multicast equals a group. And all of us are members of various multicast groups. And we all are very used to responding to multicast addresses ourselves personally. We use them all the time. And a broadcast is one to everyone. We're also used to responding to broadcast addresses. So we use these types of addresses in human communication, but we also use the same things out there in network communication. Okay. So what they're doing here is showing you a process and a progression of protocols from top to bottom in a particular protocol stack. And this is an example. So what we have, if you are trying to deliver something to a web server, let's say you're wanting to request a page from a web server, you will use the Hypertext Transfer Protocol, or HTTP protocol, and that will have the GET request within it. You will hand that GET request down to the TCP protocol operating in your computer. All of these processes are working in your computer, by the way. And the TCP protocol, in this case, will then take over managing the transmission of your request over to the web server. The TCP protocol will break your request into segments, multiple segments if necessary. If it can all be put into one segment or one packet, it will be sent off as a single packet. But when TCP breaks it up, it's called segments. It hands a segment down to IP with instructions as to addressing. IP puts the necessary addressing on it, the necessary IP addressing, and then IP hands it down to Ethernet for addressing by Ethernet, moving from one station to another within the network. So what's going on here is we can think of this very simply. Ethernet provides communication within our own local network. IP is used to provide communication to remote networks. Now, when you're trying to communicate with a local machine, because all of these protocols are in play, you will end up with all of these processes being used, even though you're communicating with something on your own network. The IP protocol doesn't drop out just because it's a destination on your own network. So you'll still have an IP header and then hand it down to get an Ethernet header. So what we have are protocol suites. In other words, a whole bunch of protocols that work together. And these protocols are arranged in a hierarchical structure, and each of these in layers, what they call layers. So what they've done is thrown at us 4 protocol suites. We don't need to know all 4 of these protocol suites. So what I'm going to do, though, is just go through, because we'll be doing primarily with the TCP/IP protocol suite, and this is a protocol stack. So the TCP/IP protocol suite at the top layer has multiple protocols, and these are just 4 of the many, many protocols that operate at what we call the application layer of the TCP/IP model. Information here is handed down to the transport layer. It's handed down to either TCP or UDP. Once TCP or UDP have assembled the information received from above into a segment and added an appropriate header for this layer, they hand all of that down to the internet layer, and they hand it down to one of these protocols here. One of these protocols will then take what was handed from above and hand it down to the network access layer, which could be Ethernet. Okay. Here we're seeing this with not all the options, just one example of a single message being sent. The application layer, which is where the services are provided, gathers your data and instructions, hands it down to the transport layer, hands it down, in this case, it's HTTP, handing it down to TCP, and then TCP hands it down to IP, and then down to Ethernet if you're on a local area network or an Ethernet network. Okay. All right. Now, what they've done over here is they've taken our 4-layer model here and giving you more and more protocols that go with these different layers. For our purposes, just note that we'll understand most of these up here eventually. We'll understand these, we'll understand actually all of these eventually, but they're just trying to let you begin to visually associate protocols with the different layers of the model. The TCP/IP model consists of 4 layers: an application layer, transport layer, internet layer, and network access layer. That's the model. These are the actual protocols that have been developed, and they have to work within whatever layer they were designed to work within. 'Cause And now we're seeing the communication process in a little greater detail, but basically what I have described to you before. Now we're adding in more information here. So what I'm going to do is I'm going to go from my web client over to the web server. I am going to have some data sent. In this case, HTTP will assemble the data. It will hand it down to, it'll put a header on it and hand it down to TCP. TCP puts a header on it and hands it down to IP. IP puts a header on it and hands it down to Ethernet. And Ethernet sends across the wire all of that which has been handed down. So this is called a packet. And these are called headers, and the data would be the payload. In this case, the top layer contains both instructions and it contains, which would be the header, and it also contains the payload, which would be the data. What is really happening on the wire is a lot of ones and zeros are being transmitted. But because the receiving device is speaking the same basic language as the sender, as it comes in, they're able to interpret these ones and zeros properly. This process of taking data and adding a header and handing it down to the next layer is called encapsulation. The process at the web server of peeling off these headers is called de-encapsulation. Okay, there are a lot of different organizations out there establishing standards for us. That's sort of off on another track for right now. Okay, you can refer to these later. This is very simple as to who controls the creation of IP addresses, and then these is IANA sends them out. And some more organizations. Okay. So we have a few things here: data encapsulation, which I just mentioned, and segmentation or segmenting messages. And why do we do that? Okay. Well, just so you understand, every transport media has what's called a maximum transmission unit, an MTU. And so we have to segment the packets, the data, because usually the data is greater than the MTU of the underlying media. So we have to break it up. If we break things up into segments, then what we have is the problem of reassembling the segments in the right order. So therefore, we have to assign sequence numbers, and that's called sequencing. So when we send things over, we give us sequence numbers. Now, what they're trying to show here, we've got two different people sending things over. What they happen to have in this case is the same sequence numbers, but they're showing you that these are orange and those are yellow. So if we received this and we were humans, we would know that the orange 1, 2, 3 go together and the yellow 1, 2, 3 go together. The computer here has a different way of identifying the traffic coming from this sender versus the traffic coming from that sender. You will eventually understand how the receiver keeps these two traffic flows separate. Also, it is highly unlikely that you would have identical sequence numbers. This is simply for demonstration purposes. I guess don't try this at home or whatever. Okay. So what you're building out of all this is a protocol data unit. And again, I'm not crazy about the way that they do this, but what they're trying to give you here is a label to go with the PDU at each layer. So the protocol data unit at each layer. So what we have here is email data, plus we're going to have a header. They're not showing you that, but actually there's going to be a header here. All of that at this layer is called data. We hand the data PDU down to the transport layer. The transport layer puts on a header, adds the header to the data, and what comes out of here and is handed down there, we call that a segment. The internet layer is going to add on a header. It can add that to the transport header and data that was handed to it. What we call that at this layer is a packet. Now, this is a little bit confusing. You may have done packet capture before. If you're on an Ethernet network and you engage with what's called a packet capture program, what you're really capturing are frames. But we call it a packet capture. So what it turns out is that we can use the term packet to apply to any of these layers, but technically what comes out of this layer is termed a packet. We then hand it down to the network transport layer, and all that's handed down gets a frame header and a frame trailer put on. This is called a frame at this point. Is that then put out on the wire as bits, and what crosses the wire are ones and zeros through encoding, electrical signals or otherwise. This is a lot to absorb. Let me just check in here. For how many of you is this all review? Nothing new here. Is there anybody here that this is all review? You could tell me all the layers. You could have given me all this information had I asked it.
50-50.
Okay,
This-
50-50.
Yeah, this is somewhat review.
Right.
For me, it's kind of new.
Okay. So if it's 50-50, then we're doing okay. If it's review for you, Armando, we're doing okay, because that's part of what this is going to be review for you. But is there any question? And for Georgiana, if this is brand new, I would think it's happening too fast for you to fully say you own it yet. Now, you might understand it as it's happening. I don't know what your background is exactly, but this is a lot of information being thrown out in these slides right off the bat. But so stop me if at any point any of this is not clear. To some degree, as we keep working with these terms, they will become second nature to you. For right now, however, we're assuming that they're still pretty new. But this is the language actually of networking. This is really what we're talking about, is the language of networking. And so when I use this language out there with somebody, if they're networking, if they're networking proficient, then they understand what I'm talking about. I say, well, did you look at the frame header? They'll know I'm talking about that right there. Oh, did you check the frame trailer? They'll know I'm talking about that. What about the transport header? The TCP header. Better check that. A lot of security involves understanding all of this and then understanding in much greater detail what each of these headers might be made of. Because a lot of attacks are crafted by way of modifying information in one or more of these headers. That's actually what a lot of attacks boil down to. You're changing something in all these, in one of these areas or more. And that's something that you're changing. If you're a network administrator, then you need to understand the terminology and why they would do that, how it might work, and what you're going to do to combat that.
So I've never had to write a program that goes deeply into each packet. Mostly, you know, I've done things where get something from an iPhone or web server, and I've done ASCII dumps and looked at the stuff to make sure that I got the right data,
Mm-hmm.
but never so deep that I had to go and investigate what each header meant.
Okay.
It's
Well,
kind of, when you write a program, it's you don't see all the little details because usually the API handles it for me.
right. Okay. So there was a friend of mine who was working in the bank, and she in a bank where I was going into, and she was familiar with networking, but she was only working on the database. And I once sort of joked with her that when things aren't working, she talks to the people at layer 3. She knew just what I was talking about because her database program was working just fine, but something down in here wasn't working fine. And this is where your routers and your switches and your firewalls are primarily operating. So again, if you're only working up here, all this, it's like, you know, if you're a car mechanic, you don't know how to repair the street out there. If this, you know, street has potholes or the traffic lights aren't working, you know, or something like that, you're working up here with the actual data. And if you're down here, then you don't know what's going on up here. It's almost like if you're down here, you're let's say driving the FedEx or the UPS vehicle, and you don't know what's in the packages. If they got the packages wrong, that's not your problem. You're concerned with getting the packages to the destination you've been told. So that's why we have, you know, different specialties. And why, but if we're trying to understand networking at this point for CCNA, we need to understand a lot of it, not all of it, but a lot of it from top to bottom. Okay. Now, the de-encapsulation is simply reverse of the encapsulation process. So the receiver gets a lot of bits, a bit stream, and then begins to digest that and determine what parts of that bit stream are the actual frame, take off the frame header, hand it up to the next layer that is going to examine the packet, take off the packet header, hand it up to the transport layer that will take off the segment layer, segment header, and then hand it up to the application that would generate or receive the data stream. There's actually a little bit missing here. Even the terminology is right as far as what we label it, but as far as the concept, what the segment layer goes up to, you know, what we would call the data or application layer, but there's a process up here that is actually being handed to. Okay, let me get my thing out of here. Now, what they've done for us here, sometimes this drives me bonkers. I don't know if it'll drive you guys bonkers. It drives me bonkers because they just switched protocol, they just switched models. We were working with the TCP/IP model. We're now looking at the OSI model, okay? As far as the labels and what they mean. So it's okay. So let me try and describe what I mean by that. We're now looking at something called the physical and something called the data link. Those are two different layers in the OSI model. In the TCP/IP model, they're one layer called the network access. All of this does take place in the network access layer. In the OSI model, they break it down, the functionality down to the different layers. The network layer in the OSI model is the internetwork layer, or the internet layer, in the TCP/IP model. And the transport layer in the OSI model is called the host-to-host layer in the TCP/IP model. So they've switched labels on us here without telling us anything as to why they did that, but it eventually makes sense, I hope. Let's see what we got here. Logical addresses. Now we're suddenly talking about logical addresses. Well, when I was drawing my little on the whiteboard earlier, I was showing you communication within one network, and I only showed you one address, a physical / Ethernet, NIC, etc. address. I only dealt with that address because the communication was taking place on one network, and if that was always the case, there would not be the need for what we call a logical address. But if I'm going to communicate from one network to another network over a router, then what we have to do is assign network addresses. And those addresses are called logical addresses. So a logical address has a location parameter to it, whereas a physical address does not. So let me give you an idea. Let's say that well, let's see if I can move. I'm having, okay, there we go. Okay, so let's say that this machine here and that machine were on the same network. I could take the Ethernet card here and swap it out for the Ethernet card in the server. And now it would work just fine, even though what I had, this used to be addressed one thing, now it's addressed something else, but it would work just fine. But if I were to take the address that's assigned to this machine and swap it out with the address that's assigned to that machine at the IP layer, at the logical address, it wouldn't work, because the IP address has a location parameter. So this IP address is telling the world, when it interprets it properly, that I'm on a network here, and this guy over here is saying I'm on a network here. And of course, we can see there's information that would let us know, actually, that they're different networks, but that's because we would understand IP addressing at the point we'd be analyzing that, okay? But a logical address,
Is the web server address, that one you have up, is that unique in the world?
okay,
But-
so
but-
here we go.
But the
We're not-
192 is not.
I'm sorry, what?
The 192 address, all of those are not unique. In other words,
Okay, in this, here's what's going on. Let me explain and answer your question. So in the world of the internet, this is not necessarily the internet for our purposes, for this diagram purposes. In the world of the internet, every two devices that are communicating directly, and not directly in the sense of next to each other, but do not have something in between them and the destination that's doing what's called translation. Every device that is on the internet itself has to have its own unique address, okay? Now, because of the problem of running out of addresses, they created groups of addresses that are called private addresses, and those private addresses are not unique in the whole world. They are only unique within the environment in which they are assigned. Okay? And then what happens is there's a translation that takes place when those devices communicate outside of their own network. So let's say this is a company here. Inside this company, I could have 192, 168, 1 dot something, 2 dot something, et cetera, et cetera. I can have all sorts of different addresses. And some other company out there in the world could be using the same addresses. But what's going to happen is when I send a packet out and it is going to cross let's say this is the internet, it's going to be translated into an address that's unique on the internet to go from this end to that end. Over here, they're using private addressing. 172.16 is a private address space. that same thing would have to be happening over here. There's a translation. We'll get into that. It's called NAT, Network Address Translation, and PAT, Port Address Translation. So you will learn about private addressing and public addressing. Okay?
Yeah, so that's the 192 usually is local host, right?
Well, the 192 is local, but it's also private. Okay? Because that's a private address. That's a private address space. Local means within our own network. Private
So
means
what I'm trying to say is 192 da 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 da. That could be an address of my laptop. And my next door neighbor can have the same
yes.
address.
Your
Well,
network,
that's what
your
I'm saying.
your next door neighbor could have exactly the same
Yeah,
address because
Okay,
each
I
of you,
understand it.
huh?
You explained it how I thought it was. So all is good.
Okay, good. So an IP address contains two parts. Let's just keep it simple. There's a network portion and a host portion, and we will figure out later as we go on how to determine which is which. But the network portion is first, the host portion is second. And the question is, where does one stop and the other start? Okay, devices on the same network. Okay, they're throwing so much at you that, okay. So what we have here is two different Ethernet addresses. Okay. PC1 has that one, PC2 has that one. Notice there's nothing in common between those two Ethernet addresses, but they're both on the same network. And so they do have in common the network portion of their IP address. And they're showing you that here. They both have 192.168.1, 192.168.1. Okay? Stop me if you have any questions. Again, we're going to get into IP addressing and it will become clearer to you, hopefully, if there is any question about it. Okay. So now they're simply saying that when we build this packet, we have the data link header, Ethernet frame header, is going to have a destination source address in it that are MAC addresses or physical addresses or NIC addresses, etc. They're calling them MAC addresses here. When the network layer adds their header, they'll have a destination and source address. It just turns out that in the IP packet, the source is first, then the destination, whereas in the MAC, the data link header, the destination is first, then it's the source. Same concept, it's just they're ordered differently because the way the protocol was designed. Just wanted to make it more confusing for us. When we're going to someone on a remote network, then the network portion of our address will be different than the network portion of their address. And routers will carry information about remote networks. In other words, networks not directly connected. So this router here has to know something about how to get to that over there. It may not know about that network. It just may know that if it doesn't know, if it's not one of its directly connected networks, that it sends it over there and that's on its way. And eventually someone over here knows exactly where it is. Okay. All right, so they're now introducing the concept of a default gateway, and that is the router to which you send your packets that are going to remote networks. It's really that simple. And it's pretty much the concept of like this. Let me just say that you had a letter, you write this letter out, and you put it in an envelope. And the letter is supposed to go to your next door neighbor. Okay? What you could do, you just walk over there and put it into your next door neighbor's mailbox, right? Directly deliver it yourself. But let's say that the person you're sending the letter to lives in a different state. Now, what do you do with the letter? Well, you have to put the proper addressing on it, but then you have to get it to the post office. Now, that could be just the outbox on your desk. It could be your own mailbox. It could be a mailbox sitting on a corner. It could be the local post office, whatever. You've just got to get it to the post office. Wherever you go to drop off a letter to go to some remote destination, that would be referred to as your default gateway. And of course, you may not use the same one all the time, but in the world of networking, we generally use the same default gateway all the time. If we want to send something to a remote network, we send it first to our default gateway, and that is an interface on our network facing us. In other words, an interface on a router facing us on our own network. Okay. What they're really trying to tell you here, and again, we're just sort of saying the same thing. Ethernet addresses are used to move a frame or packet from one device to another device on the same network. IP addresses are used to move a packet from one network to another network that's remote. And remote meaning not your network. There's only two ways to describe networks in the world for what we're just saying right now. All networks are either local, which is our own network, or the remote, which means that they're some other network. So all networks are either local or remote. Okay, so that's for local addressing. And because of that, you could actually have, without any translation, you could have the same physical or MAC address on two cards if they were on different networks. You will not have any conflict. Okay? So the only time you have a problem with a conflict of MAC addresses is if you have two MAC addresses on the same network that have the same address, if they're duplicate addresses. Very, very, very seldom happens. But if there was a foul up in something along the way, it's possible to have it happen. Very, very unlikely. But you do not have to be unique from one network to the next. Because the way network cards are manufactured, generally they will be, but you don't have to be. They're trying to show you something that's a bit involved here, and this is the communication process. That we're starting here, we're going to want to go out here. Our MAC address is going to be, our source MAC address will be us, destination will be that, to go across this link. When we cross that link, the source MAC address for the frame will be that, and that will be the destination. When we cross that link, the source MAC will be that, the destination MAC will be that. But the layer 3 header, source IP and destination IP, will stay the same across the whole transmission. And you will get questions on the Cisco exam, probably more than one question, that deeply tests your understanding of just what we described there. And this is what's going on here, what I just said, as far as what changes across the addressing. And the packet is not modified, but the frame is changed. What they mean is the packet, the header, layer 3 header, is not changed. And of course, now they've switched to calling the layers based upon the OSI model. So when we say layer 1, 2, 3, or 4, those are actually referring to the OSI model, not the TCP/IP model that we were originally presented with. The OSI model has 7 layers. Generally, we don't refer to layers in the top 3 or the upper 3 layers individually, though you can. But we do use the terminology of layers 1 through 4 to describe specific things happening at those various layers. So a MAC address is at layer 2, an IP address is at layer 3, a TCP header is at layer 4, and the bits going across the wire are actually layer 1. How are we doing as far as time here? I'm yakking away. I can't see my clock very easily. You guys want to take a break? Oh wait, we're done with this module. So yeah, let's go ahead and take a break. And let me see what the clock move this around. Oh, okay, 7:15. Good. Okay, so let's take a 15-minute break. We'll come back at 7:30. Okay, I'm going to pause the share. I'm going to pause. Okay. I'll wait till you folks. Back. Okay, folks, just let me know if you're back. Thank you.
Back.
Georgiana?
Back.
Okay, and George? I'm Roger.
Back. That's
Okay,
what I-
great. Away we go.
Alright, I'm here too.
Okay, let me get that thing over there to one side. Okay. So now we're going to look at the physical layer. Physical layer. Okay, someone's got they're you need to mute, Georgiana. I think you need to mute. Oh no, Roger. I think you need to mute. There we go. Okay. So what we're going to do with the physical layer is simply transport the bits from one device to the next, whether it be wireless or wired. And in this way, we're going to get the packet, the overall packet, protocol data unit, across to the other device. So here we see now the OSI model. And let's see if I can get that out of there. Oh, there we go. Good. Okay. OSI model. So we see there are 7 layers. Physical data link network transfer. Da, da, da. Okay. Here's a mnemonic that's used. All people seem to need data processing. That's the first letter of each of those. Okay. And what we refer to generally, when, as I said earlier, is the bottom 4 layers, both by label and by number. But generally, we don't talk about layers 5, 6, and 7, except to be pretty much all at the application or upper layers. So the physical layer has a lot of standards that are applying to it, as we see over here. And we'll learn about some of those. So we have the areas of the components themselves, the encoding, and the signaling. So we'll see how that works. So encoding is basically how do we indicate that what we have just sent is a 0 or a 1, and it depends upon the encoding method that's used. Now, what we see here is the Manchester coding, but there's also another type of coding called 4B, 5B, 8B, 10B, but those are all different encodings. We don't really generally, unless you are very much working in the physical layer and having some problems there, the devices pretty much work without us having to worry too much about what encoding method is actually used. There are some situations where you might run into a need to fiddle with that, but for the most part, especially in Ethernet, you just, well, this is the way it works. So you have a certain voltage level, and to indicate a 0, in this case, you start here, you drop down over this time. This is a time period. You drop down and you stay at that level. Now, if you want to indicate a 1, you then jump up. And then we see here a 0 goes back, drops down, and then goes all the way back up to the base there. And all they're showing you is this series of signal changes will indicate to a receiver that it's in that time frame a 0 or a 1, so forth. So that's all we're doing binary transmissions. So everything is either representing a 0 or a 1. And that's what they're saying here. And there's all sorts of different ways of indicating changes. Okay, so you have frequency, phase, and amplitude. That's what they're looking at there. So this is just telling you the numbers, how they're calculated. Some terminology that goes with this. Our latency will be delays based upon signaling delays, collision delays, whatever might be involved that would cause things not to actually work immediately. And then we have our throughput, and of course our good put, as they put it here, is actually minus the traffic overhead, all those headers that are needed to make it work. And we're going to breeze through this pretty much because a lot of this stuff, there's not really much that I can add to it that's beyond what's in the slides here. But you're going to want to understand copper cabling, the different types of copper cabling that's out there. Unshielded twisted pair, shielded, and coaxial cables. So you can see that they each look a little different and have different characteristics. You'll want to know UTP, unshielded twisted pair, and sort of what's going on with that. So we have 8 wires here, and in 4 bundles. We have a RJ45 connector that we'll use at each end. Shielded twisted pair is basically the same, except that now we have some shielding to prevent corruption of the signal as it's traveling through the wire. And coaxial cable, of course, this is what we have coming into our homes if you're using cable. And these are our different types of connectors. This is a BNC connector, one of the more common, but we also have these for networking. Okay. All right, so a few things that you want to note here is that the twisting helps cancel out the interference that you might get. That's why you use twisted pair. And we have all sorts of standards established, these different categories, and it depends upon the number of twists. You see here how many twists you get is often what is associated with the different levels of the different categories there. Here's our RJ45 connector. And this is how it should look over there. And you'll want to know these for exam purposes, but basically when you're out there, you're using either straight through or crossover. You'll get used to using those and be able to distinguish those pretty easily. Fiber optic, of course, using light inside of your cable, and you'll want to go through these, understand the various types of fiber media that's out there, single mode versus multi-mode, and some of the characteristics associated with each. Okay, I'm going to go through these fairly quickly because we don't need this for what we're trying to do in our course pacing. We don't need to spend a lot of time on this. Okay, and then wireless, again, you'll want to go through and understand these different things. These will be test questions. You will want to know a little bit about these protocols here, 802.11, which is the primary one for wireless, and your Bluetooth. And of course, we have wireless NIC adapters. You folks all have those in your either laptops or computers. There are some that just you can plug in with USB, and then your wireless access point, which would be also in many cases in your homes, would also be your router. Okay, so that takes us through that one. Let's go to module 5. All right, so we touched on this a little bit. I always like to start with using hex because it's easier. It only uses 4 bits, and then we'll see how we get to IP version 4 and so forth. Now, let me ask, just to start off with though, how many of you are well versed in IP addressing? In other words, you understand how to subnet? How many of you understand how to subnet an IP addressing?
I don't.
You don't. Okay.
I need like a refresh, but
Okay.
I know a little bit.
Okay. So yeah, you covered it in class, but okay. And Roger, how are you? Do you have some background in subnetting or?
I did some of that using when I had Amazon Cloud and
Okay.
asking.
Okay. I'm going to try and have the slides help us out here. I have my own approach to subnetting, and actually that's one thing you can say about IP addressing and subnetting is that you'll get a different approach in explaining it from every instructor that you take. Every instructor has a little different approach. How much they work in binary, how much they use the shortcuts, what tables they use, and so forth. There's all sorts of ways to approach this. But what I'm going to do is try and use the slides and augment them because it's tough to flip back and forth between a whiteboard and the slides in this case. Okay. Let's not, okay, so now we're working in binary, okay? And what we have are 8 bits that we're working with when we're talking about IP addressing, 8 bits that we're going to translate into some number. And here are the positions. So in the first position, and this is only the value of a binary 1, okay? So if there is a 1 in this position, it's worth 1, here 2, 4, 8, 16, 32, 64, and 128. So you see that it's simply doubling as you move from right to left. Okay. And of course, it's halving as you move the other direction, which is important to keep in mind for certain exercises. So if we have a binary number, like 11000000, and this, by the way, this positional value up here that you have right there that they're showing you, generally you're going to write this on the top of a piece of paper that they give you when you take an exam. Because, and you may write more than this, you might actually write out a table. So you might combine some information from this table here, the lower values there, into a table that has that across the top. But in any case, you'll have this written on your test because you'll be trying to do subnetting. And for the most part, you'll need a table to make sure that you're doing it right. You get really good at it, you can do it in your head. But I don't know if you want to do that to yourself, you know. You become very popular at parties, though. If you know IP subnetting in your head, everybody at a party wants to talk to you about it. So I'm joking, of course. You'll become very unpopular. Okay, so if you have a 1 in any of these positions, it's worth the value indicated for the position. They're giving us as a sample here 11000000, and they say translate this into a decimal number or represent this set of binary numbers with a decimal number. And so here we say, we've got a 1 in the 128, we've got 1 in the 64, and all the rest zeros. So 128 plus 64 is 192. There you go. So we've just translated a binary string of 8 bits into a decimal number. Okay. So these are multiple examples here. So this is the one we just did. Okay, 192. Let's see if we, okay, 101010000. Okay, 128 plus 32 is 160, plus 8 is 168. Here we go, 0001, 011. This is 8, plus 2 is 10, plus 1 is 11. Is 10, okay. So what you want to do is become fairly adept at being able to take a string of 8 binary numbers, ones and zeros, and translate them or convert them to a decimal number. So here, we see here 32 total. Well, it turns out that that's what an IP address is. An IP address is 32 ones and zeros, but the way that we express it generally is with 4 decimal numbers. So we group the 32 bits into 4 groups of 8 bits and express each of the 8 bits as a decimal number. And then this is what we come out with at the end, 192, 168, 11.10. Now, earlier, what I said was that this IP address has 2 parts to it. It has a host part, and I'm sorry, it has a network part and a host. Network is first, host is second. The question is, which of these bits are network bits? Where do the network bits stop and where do the host bits start? If you were to look at this and make a guess, you would probably be right because of the nature of implementation of IP addressing out there. But honestly, there's no way you can tell from looking at these 32 bits and these 4 numbers where the network portion stops and the host portion starts. You can't know. What we'll see, what we need is another number. We need some other number that we can use to compare to this to tell us how much of it is network and how much of it is host. Okay. And this is really just, again, talking about converting the two over, okay? And another, yes, yes, no, no type of thing. If this helps you, it doesn't really help me. I would just look at, if I had this on the top of my page, I put this underneath and I go 128 plus 32 is 160 plus 8, that's 168. That's what I would do. If you had to write that down to add it, that's fine. You can't use a calculator in the test. You cannot take a calculator in the test with you. And here they're just showing you the result. Okay. Now we are all well versed now in hex, and this is the range of hex numbers 0 through F, and these are the binary representations of these hex characters. They're actually not hex numbers, they're hex characters. So whoever created hex decided that hex would consist of course, just 4 bits, and they'd start with 0, and they would go down through until they ran out of numbers. They said, let's switch over to the alphabet. And they decided to start at the beginning. Did not have to come out this way, but this is, the most reasonable way to have done it. And thankfully, it's bad enough just being that way. Okay, so this is hex to IPv6 addresses. Well, in IPv6, you have groups of 4 binary groups of 4 binary numbers, and essentially what you do is you just convert over on each one, each group of 4 to a hex. And if you've got decimal, you can convert that to hex as well. Again, that doesn't help us right at this time. All right, let's go ahead. Any questions about this so far? Now, what I said last week is that we were going to get into a bit about packet tracer and scenarios. And so what I want to do.
We went through module 3 the previous hour, and now we are to module 5.
We went through 4 briefly, yes.
Oh, that was short?
It was short. It was just talking about the physical layer.
Oh, that was the part. Okay.
Yeah, that was module 4.
Okay, thank you.
Okay, yeah. So what I'm going to do now is I'm going to switch over to packet tracer. So I've got to do a new share here. Hang on, let's see. Stop that share. I'm going to share screen. I got to get packet tracer up in order to be able to do that. So let's open it up. There's packet tracer. And now let's go back here and share my. Where'd my packet tracer go? Oh, let's do that and try it again.
Packet tracer crashes a lot.
Oh, you have a problem with it, huh? I
Yeah.
haven't really had that. Okay, there we go. There's my packet tracer.
Mine didn't crash.
I just
You know
let
what?
it and it crashes.
Let me, you know what I realized? I really should do this. Let me flip over and send you all. Actually, let me stop. I'm going to stop this share. I'm going to send you all a scenario right now. Okay. So I'm going to do a quick and line. See. And by the way, in the future, do you guys care if I send just directly to you with each of your email addresses, or do you want them still blind copy?
I don't mind if it's shared with Roger, and I don't know, he left right now, Armando.
Mondo, it looks like he left, yeah, huh? Okay,
Yeah, I don't mind.
okay, well, I'm gonna send you PT scenario. Okay, and let me just take a moment here. Scenarios, basic two, no scenario, no configs. Okay. All right, so now what I'd like you to do, I just sent by email a scenario to you, okay? And let me know if you got that. You can see what I have on the screen, but I'd like you to also see this in your environment there. So if you guys can open up Packet Tracer and then open up the scenario that I just sent, your screen will look like my screen. Have you guys, let me know when you have that up. First of all, did you guys get the email?
I got the email and I opened the PKT file.
Okay, so your screen now, you have that as well as you have it on my screen. I have it on my screen and you have also Packet Tracer open on your screen. Is that correct?
Yeah.
Okay. Roger, is that working for you? Roger, I don't know if he's still with us or no, he out.
Maybe he will come back. I'm not sure what happened.
No, I don't know what. Of course, you guys are having storms down there. I don't know if they're running into internet problems because of the storms or what, but
But you are not in SoCal right now?
I'm not in SoCal. I'm actually in Southern California right now, but I'm coming up this weekend, so I'll be in SoCal Monday night.
Oh, you said SoCal and you really meant Los Angeles or something.
No, I'm going to SoCal, but
Yeah.
I'm now in Southern California in Palm Desert. And
Okay.
yeah, so I'm in SoCal and I'm going to SoCal. But anyway,
Yeah.
so let's just look at this scenario here, first of all. Okay, let's talk about this scenario. Roger, are you with us here as far as do you have this up?
I know I kind of I hit the wrong button and everything is
Okay, can you see what I have on the screen?
yeah, I'm trying to get it back up to my main screen and all that stuff.
Okay,
So no, this will never happen in a real
in the real
situation,
world?
but it is how we live now. So
Yeah. Now, Roger, you're over in San Jose, correct?
yes.
Yeah. I don't know if you're having outage or a lot of rain problems over there. I know. And Georgiana, you said you were approximately where in near Aptos, not too far from Aptos?
I'm very close to Cabrillo College, actually. I'm like maybe to walk 10 minutes.
Oh, wow.
But I am in, some people say SoQual, some people say SoCal, I don't know.
No, it is SoCal. It's not so cool.
Okay, it's SoCal. That's where I am.
SoCal.
Off of, next to AJ's, very close to
Oh,
AJ's.
yeah. You're right next to AJ's. That's yeah. Well, you know where Fairway is? Fairway down there by the just beyond the market. The quick stop, the quick stop market.
Yeah,
Yeah, well, I live off of Fairway. That is just the stoplight beyond the quick start mark, quick
yeah,
stop.
I know where it is. Yeah.
Okay. All right, Roger, you ready for me to sort of go over this and explain what's going on with this here?
It's probably be a couple minutes until I've downloaded and found the location and all that.
Let me just. There's Armando's back. Welcome back, Armando. Yeah, you guys are getting a lot of rain and storm down there, up there, I should say. Okay, so let me talk about the scenario first, okay? And then we'll get into what we're going to do with it. First of all, okay, so this is a packet tracer scenario. And in this environment, I have two routers. The routers are shown by these symbols here. And as you see down below, if I wanted to bring a router in, I've got all these different choices. So tons of different models of routers that I could bring in. I've already created this scenario, and I believe, yeah, these are 2621s, both of these, okay? Now, these routers are connected across a serial link. And that's why that thing is a jagged line like that. And in this case, it's a point-to-point serial link. So this is one end, that's the other end. We'll learn about serial links later on. But basically, if something is sent out here, it's going to end up there. Out this end, we have an Ethernet environment. And Ethernet could have multiple workstations. So I could add workstations if I came down here, for example, and went like that. And I wanted to put another PC. I could put another PC here. And then if I wanted to cable that, I could then put in some cabling there. This right here would be a straight through. And then I could go up here and I could connect it to that, for example, then come down there and connect it to my fast Ethernet and bingo. And now I've added a workstation in. So that's how we do that. But out here off this switch, I can have, you know, as many workstations, I mean, as many as I would want for this environment. You obviously are limited in the real world, but these are workstations down here connected with Ethernet to a switch. And then the switch is connected to the router through Ethernet. We notice that this is red. Well, why would that be red? This is red because this interface on this router by default is shut down. And let me just see if it drops down there if you happen to hover over it just right. But the interface is shut down. So is that interface. So one of the first things we're going to try and do with these devices is we're going to, first of all, try and bring up the interfaces after we give them some names and little things. But I just want you to understand the basic environment: router, switch, Ethernet network, wide area network, point-to-point connection, serial connection. Again, same thing over here. And what this is intended to be addressed, now, these things haven't been addressed right now, but we're eventually going to address this is 172.16.1.0 or some host number over in this environment, 172.17.1.0 in this environment, okay? And eventually what we want to achieve, once we understand how to configure the devices properly, is we want to be able to communicate from any device in here to any other device. That's what we would be looking to achieve. So the first thing I'm going to do is I'm going to click on my router, and I think what we have is a problem. What I've had in the past is when I click on this and I go to, let me just see if this is going to work. When I go to the CLI, you probably don't see this. You don't see my CLI. Is that correct? The picture, nothing's changed for you in your environment. Is that correct?
The router one is faded. The color is faded, but
Other than that, nothing. Okay, so that's
no.
it's the problem that we have with the sharing. Let me do, I'm gonna stop the share and see if I can now share the CLI that I just brought up, okay? So. Okay, here we go. Here's the router one. I'm gonna share this. I forget what I did. Okay. Last year. So when I clicked on the router, this is what I come up with. This is the CLI, the command line interface. Now you can't see the scenario anymore, but you have it on your screens. You have the scenario. And
Which
right
router do
now,
we click?
go ahead.
Well, the trouble I'm having is I only have a MacBook Air, and with everything running, I'm getting a little too many spins. So
You don't need to, you can close down Packet Tracer if you want. You don't need to be working in this. But I want to demonstrate this for you now, and then you guys can we can close off the Zoom and you can practice on this.
no, it's so when so I've clicked on router 1 and router 2. I don't see any CLI. Is it a single click, or I'm on a Mac, so I don't have a right click?
Well, it should be the same on the Mac, but if you click on router 1, just click on router 1,
Yes.
and you should get another screen. It should say physical, config, CLI, and attributes. And
Okay,
then
I see it. Okay.
now click on CLI.
Okay, I got it.
Okay, so now you see in yours what I'm looking at. Is that correct?
Yeah.
Okay, so we're going to now explore the CLI a little bit. First of all, I'm going to press enter, and every time I press enter, I get a new line. Okay, right now, here's my prompt, router, and then greater than sign. So router is the host name by default for the router. We're going to change that. And the greater than sign indicates that I'm in the user exec mode, not the privileged exec mode. I have to be in the privileged exec mode in order to be able to change the host name. But right now I'm in the user exec mode. To get into the privileged exec mode, the command is enable. I press enable, and you notice how the prompt changes. I'm now seeing the pound sign. That tells me I'm in the privileged exec mode. If I want to come back out of this, I can simply go exit, press return, and I'm now back in the user mode. I want to go into the privileged exec. Now I want to show you something. The only command that starts en is enable. So I don't have to type enable, I can just type en. The other thing that you should know about, you can do, and this helps as you're learning, is called tab completion. Right now, I'm going to press the tab key and watch what happens. It gives me the enable command, okay? Because it was the only command that started en, it completed that just by pressing the tab key. That's a good idea. Go
Yeah,
ahead.
that was in our homework.
What's that?
That was also in our homework.
Yes, good. So this is just so that you can practice a little bit. And if you if you use the tab completion, what will happen is you'll see the commands, because what you might find out on the test is they don't let you have as an answer en, you'll have to say enable. And so you want to get familiar with the full command. Later on, use the shortcut. So I press enter, and I'm back in the enable mode. Now, what's the difference? Well, let me show you. I'm going to exit again. I'm going to come out of this mode. And I'm going to do a show. Oh, I'm going to, first of all, just do a question mark. So this is context sensitive help. I go question mark, and it shows me all of the commands that are available. Now, this is a simulator. It's not an actual operating system. Okay, this is a simulator. So this if I was on a real router, it wouldn't look exactly like this, but they're trying to make it look pretty much like a real router. Okay, but I just put a question mark in, and you notice I have a number of different commands here, but I, don't have a ton of them. Now I'm going to go back into the enable mode, EN, press enter. Okay, and now I put in the question mark, and look at that, all those commands that I have. Now notice something here. I put in question mark, it's showing me all the commands, but down here it says more. When it says more, if I press enter, I get one more line. If I press the space bar, I get another page full. In this case, there wasn't a full page full, so it just took me back to the prompt. But if I put in that question mark, if instead of pressing spacebar, I just press escape, it doesn't give me any more. It just drops me back at the command prompt. So you want to learn those 3 different shortcuts. Enter gives you one more line. Spacebar gives you another page worth, if there is that. And escape takes you back to the prompt. Okay? Now, what I want to do is change the host name, and I can't do it at this level. I have to go into what's called the global config level. And so let me show you how we do that, and I'm going to explain as we go along. So if I type config and press, the full command is configure. So configure, and then I put in a question mark. And notice I have, in this case, only the one option, configure terminal. If you're on a real router, then you would actually have more options. But for us, the only option is terminal. And so I only have to press T and then enter and that. I'm going to exit back one level and show you a shorter option, config T. Bingo, that's all it took. All right. Now notice it says end with Control Z. I'm going to go Control Z, and I'm back at the upper level. Let's try this again. Now, here I'm going to show you something else. I press up arrow. Up arrow brings back a previous command. Up arrow, enter, I'm there. Control Z would take me out. So would exit take me back one level. So we have multiple ways to move up and down. I've up arrow, brings back the previous command. And now I'm in the global config mode. I see that it's called router config. And I want to know what command would I use to set the host name. So I'm going to put in a question mark. And I look down there and I see a command called hostname. I'll bet hostname is the command that sets in fact, that's what it says, sets the system's name. So I'm going to press escape because I don't need any more output back there. And I'm going to put in the command hostname. After hostname, what do I put? I'm going to put in a question mark, context sensitive help. I'm going to put in some word that will actually be the network name for this router. Now, as we see, you can't see it. At least I can't show you, because if I share the other screen, then we lose this. But if you remember, the name that I want to give that router is router 1. So I'm going to call it router 1. Can't put a space there. And watch what happens when I press enter. Instantly, it becomes router 1. So now the host name is router 1. Okay? Is everybody with me so far? I'm trying to take this a little step, each of these a little step at a time.
Yeah.
Okay, good.
Yeah.
Okay, now, if I want to move back up one level, and I'll show you why. I'm going to exit. Now, I've changed the host name, but where have I changed the host name? I've changed the host name in the running config, but the router will not save that if I turn the router off right now. What the router boots to each time it boots is the NVRAM, or the startup config. So what I want to do is I want to see the difference. I want to look at the running config, which is the configuration that's actively running the router, and I want to compare it to the startup config, the configuration that is in NVRAM that will be used upon reboot. So I'm going to do a show, and then I'm going to type run and press tab, show running config. This will tell me the active configuration. And what I see is right there, host name, router what? Okay, that's in my running config. Escape, because I don't need to see any more. Show startup config. Press enter. Oh, the startup. So there is no startup config right now. I haven't saved anything. So right now, if I were to reboot, I would end up with just some default configuration that is set for all Cisco routers. And it has just some basic defaults that are displayed. So what I'm going to do now is I want to save the running configuration to the startup so that when it reboots, it has the same host name. The way that I do that is with the copy running config to startup config. That's the command, and we'll shorten that to copy run start, and we'll have even a shorter version of that later. But copy running config to startup config. It prompts me, oh, the destination file name is startup config. Well, this is good. It's prompted me, and you should know that when it gives you a prompt like this, all you have to do is press enter. And if you press enter, you will get what is in that particular brackets. Building configuration, okay. Now we'll do a show startup config. And there we go. We have the same thing that we have in the running config. We have hostname router 1 as the configuration. Escape to get out of the display of configuration. I'm back at the prompt. So now I very simply changed the host name on my router. That's all I've done. Okay. Now I'm going to do a show run again, just because it's going to give me information about interfaces. Now I'll see what we have. I'm going to space bar. Okay, so one interface that I have multiple interfaces. One is interface fast Ethernet 0/0. It does not have an IP address, which I understand, and it is shut down by default. So router interfaces are shut down by default. That's a potential exam question, something you want to know. That's a security feature. You don't want a router to come up and suddenly start routing packets without you intending that to happen. So by default, they're shut down. Okay. So what I'm going to do is I want to go to the interface fast Ethernet 00, because I believe it's that interface right there. It's going that way. And I am going to bring that active. I'm going to make that active, and I'm going to give it an IP address that's on this network. And it's 172.16.1.0 is the network. We didn't get into the /24, but that means basically the first 24 bits are network bits, host bits are the last 8. I'm going to address the router 172.16.1.1 and put in the proper network mask that goes with it, which would be a 24-bit mask. We'll talk about that later. They didn't really go into it there, but I'm going to do that and activate the interface, and we'll see if we have any different result on our screen here. So I'm going to escape. Now, to get to the interface configuration mode, I have to walk down through the global configuration mode. I can't go directly there. I have to go first to global config, and then from global config to interface config. So interface config is actually a sub-configuration mode of global config. To go to global config mode, enter. Okay. Now, to go into the interface configuration mode, I go interface, fast Ethernet, 0/0, and press enter. Okay, so now instantly I am in the interface configuration mode. I can tell because it says config IF, but it's sort of strange. I don't know what interface I'm in, except that I just entered that. So I'm probably in 0/0, right? If I was not sure what I was doing, it would be good to re-enter that command to make sure. You don't want to just I can, a lot of commands have been entered and I couldn't see it right there anymore. Be best to re-enter that command to make sure you are in the right interface. Okay, now to bring an interface down, it's the shutdown command, and that's what we see right here. Shutdown takes an interface down. To reverse the command, you put a no in front of it. So it's no shutdown. No shutdown. Press enter. And we see things are there. Now, if you were to do that on your machine, on your packet tracer, what you would see is that the interface was going green, and it also was, there's an orange ball. We'll talk about that later, but for right now, we'll accept that the interface is now active. It is no longer shut down. Okay, and then I'm going to give it an IP address. And the command to give it an IP address is IP address, amazingly. And the IP address is 172.16.1.1. That's the address I want to give it. And the mask, we'll get to this in greater detail, but for right now, is that. And I go enter, and now I have given it an IP address. Now, to get back to the privilege exec mode, to go up the 2 levels, there's 2 ways I could do it. I could type exit, press enter, type exit again, press enter, or I can just go Control Z. And that takes me all the way back up. So now I'm at the privilege exec prompt. Hopefully I haven't lost you. And I'm going to do a show run. And I'm tab completing just so you see the command, not because I need to, but. And now what we see here is, okay, I still have hostname router 1. And now I'm going to enter. I'll go do spacebar. And now I have interface FA00. Oh, now it has an IP address. And notice that the no shutdown isn't here. So that tells us that it is not shut down. If it was shut down, it would have a shutdown in it. But it is not shut down. Don't worry about the duplex and speed being auto right now. Right now, interface FA0/0 is properly configured. Okay, and it's operational.
Are we gonna learn what these terms mean, like duplex,
Yes.
auto, speed auto?
Yep. Those are all things that we would cover in depth with Ethernet, when we get into Ethernet in depth.
So when we connect these devices, does it matter right now which cable we take, except for the crossover? I know not to pick that, but on the
Yep.
other cable,
Okay.
does it not make a difference?
Okay, so it does make, you want to use straight through unless you're going from one device that's identical to another device. So you use crossover between like devices. So if I was going to go router to router using Ethernet directly, I would use a crossover. If I'm going router to switch or router or switch to host, that would be considered straight through. I'd use a straight through. Now it's sort of, you just have to memorize this, but if you're going to go from a router directly to a workstation, then you use a crossover. A router is considered to be the same as a workstation as far as cabling purposes. So I can go from the switch to either a router or a workstation with a straight through. But if I go router to router, if I go switch to switch, if I go router to workstation or workstation to workstation, any of those situations, I use a crossover.
Yeah, I've done that on my machines. That's the only time I will use a crossover. And basically, most of the time, I will use a wire other than connecting something to the hub. Usually,
Right.
it's crossover.
Yeah, when you go to the hub, you're using straight through.
Okay.
Okay. Now, what I want to do is I'm going to stop sharing here. I'm going to open up a PC, and we're going to configure a PC. And then we're going to test and see whether or not we can ping and all that. So let me what I'm going to do is I'm going to stop my share here. I'll be right back shortly with you because I'm going to be, let me close that down. I'm going to open up the PC and then I'm going to do sharing again. So now I've opened up the PC, okay? PC1 is what I've opened up, okay? And I'm going to show you how to configure PC1. You'll need to know this for the Cisco exam, even though PC1 would be actually most likely a Windows machine. So what we can do is we can go to config, trying to bring this screen down here. I'm not having much luck to move it down so that I can see it better. Let's see if I can move this off. There we go. Okay. All right, so we have all sorts of things. Let me just walk through here. We have a config, and we can have global, and we can have interface. So we can go fast Ethernet interface right there. Now we're configuring the interface. In this case, there's only one interface, so we don't have to worry about which one we're configuring. And we're going to give it an IP version 4 address right here. We're going to give it a static, means that we're going to manually assign it. And we're going to give it a subnet mask. Can everybody see my share now? Looks like you should be able to. So 172.16.1.some number. Now, I'm going to start the workstations at 10. We'll explain that later. But it just right now, anything other than 1 would work because 1 is already used up for the router. Anything other than that would work. But I'm going to start with 10 for the workstations. And then I'm going to give it a subnet mask of 255.255.255. And when things are simple in this world, where the 255s end, that's where the network portion of the address ends. So in this case, 255.255.255.0 means that of this address, 172.16.1.0, 172.16.1 is the network, 10 is the host. Okay? Now, we have a global configuration settings, and here we set the default gateway. The default gateway is going to be the router's interface, 172.16.1.1. That's the interface address that I put on the router. And now we have that as our default gateway. Now, how do I test this? What you do is you go to the desktop, and then you go to a command prompt right there. And on my command prompt, I have to know some Windows commands. And one of the commands I have to know is ipconfig. ipconfig shows me my configuration. And we see here, don't worry about this up here, connection specific DNX. We have fast Ethernet 0 connection. This is the MAC, that's the link local address for IP version 6, don't worry about it. We have the IP version 4 address that I just signed, 1.10, that's the mask, and here's our default gateway, okay? So ipconfig is one command. Now, again, here, up arrow brings back the last one, ipconfig/all, brings up even more information. And again, I do that, and I've got all sorts of information. Don't worry about that for right now, but you will want to be familiar with the ipconfig all command. So I now see that my machine appears to be properly configured. The question now is the network working? I have an IP address on my machine, an IP address on the router. I've got a switch in between The switches are very much plug and play in this world. So I should be able to ping directly. Let's see if I can ping 192. Oh, I've got to keep going 172.16.1.1. That's the router. And there we go. We have 4 replies. That means 4 successful pings to the router. That means that I have connectivity between this workstation and the router's directly connected interface, which is my default gateway.
So I have a question.
Yes.
So the C prompt, you're actually on your PC, not the packet analyzer.
No, this is a fake PC.
So
This is the,
this is not your,
no, this is not my local, this
but
is,
but it's also not the packet analyzer. So how do we do this? How do we?
what do you mean it's not a packet? No, this is a fake, just like all the devices in here are fake devices, right? This is a fake workstation.
So, oh, but I
It's-
get it. So you put up a workstation and you accessing that workstation.
Yes, this is a
Okay.
workstation within the packet tracer scenario.
Okay, so you just click on the workstation and
Yes.
you get a C prompt. Okay, okay.
Yeah, well, I click on the workstation and then across the top, I can pick one of these: physical, config, desktop,
Okay,
okay? And
I
when
missed that step.
when I go, okay, and when I click on desktop, here, let me just come out of here. Let me see if I can do this. Config. Let me see if I can get out. Let's go exit. Can I do that? Yeah, okay. So before I went into command prompt, I clicked on desktop, and then I went to command prompt. So these are different things that I can do on my PC, and they're all supposed to be Windows for a Windows PC. This is a Windows PC, not a Mac. Okay.
So I'm looking at mine. So I clicked on my PC. I click on
Desktop.
desktop.
Click on command
Okay,
prompt.
I see it. I see it. I got it.
Then you click on command prompt. Okay. And now you are there. Okay.
Got it. This is neat.
Oh, it is. It's excellent. They've done a great job. It really is a wonderful tool. So, and I don't know why it looks like I'm sort of hung up there. I'm trying to Control C. There we go. Okay, bingo, bingo. Okay. So now my keyboard operates this command prompt as though it were any command, a real command prompt, but this is a fake command prompt. This is a simulator. Okay. So if I did let's see if I do a dir, which is a command, there I go. I'm getting the results of a dir command, which is a basic DOS command. I don't know if I put in I don't think question mark. Yeah, there we go. There are all the commands that are available or that they want to have displayed. I don't know if all those commands are available to me, but those are commands that you can use on this fake PC. So it's a pretty expansive, pretty expanded program. It's really very impressive. Once you see what you have here, you have an environment that is so rich for learning. It's just phenomenal. Access to Packet Tracer is gold. There are other simulators out there you can get commercially. As far as I know, none of them are as good as Packet Tracer. This is a Cisco product. Okay. Any other questions on that? So what I just did, I'm going to have to stop my sharing here and go back into Packet Tracer and reshare that. So I'll stop this share and then share. Oh, there we go. Screen, Packet Tracer, share. Okay, so now I'm back in Packet Tracer, and I had to come out of the share and then go back in because my computer sees the router one little dialog box come up as a different application. And so that's just a little quirk with the sharing. If you're in Packet Tracer, you can do all this, of course, directly on your desktop and not a problem. Now, let's go to this router because this is here and it's okay, but this is a default naming. I put this in by adding text. I want to take and have this not displayed. So let me go back here to the config and the display names, router one. Let me just see. Why am I getting that? Global. Global settings. I don't know why. Physical. I don't know why I'm getting that. Because router one is what I've got there. So that should be what I'm getting. Okay, I'm gonna come out of that. All right. Yeah, I'm gonna get rid of that. I don't think that's in there. No, that's not in there for text. Okay, escape. All right. So I have two routers. We do not have connectivity here. As soon as I go into the router interface, into the router command line, then I lose you folks because of the sharing problem. But basically, we have connectivity between these two. I do not have connectivity between these devices and this one because it's not configured with an IP address. I'm working through the switch right now, but I can't communicate to the switch because I haven't configured an IP address for that either. Okay. Any questions on that so far? Okay. All right. Now, well, we've taken only one break tonight, so we really could wrap up pretty soon. If there's anything you'd like to go over, I can review what I've done here if it would help. But we're pretty close to wrapping up because we didn't take a second break. Normally I would take a second, 2 breaks in the 3-hour time period. But what would be good for you folks if you would take, maybe the remainder of class to just do what I did on the scenario that I sent out. Armando, I think you probably got that scenario. So just go ahead and configure the router with a router host name, configure an IP address for fast Ethernet 0/0, do a no shut on it, do this, configure the workstation as I configured that with an IP address, default gateway, and then just test connectivity between the two, and you should be able to ping from one to the other. I can show you, let's do this. I'll have to unshare and share again. So stop my share screen. And now I'm going to share. So now I'm at the router CLI. I'm going to exit. And I want to test whether I can reach the workstation. Now, I've already pinged from the workstation to the router, so this is slam dunk, but I do want to show you something. Okay, ping 172.16.10.10. That's the workstation. Press enter. Okay.
No, it's
And
the .1.10.
what?
Is .1.10.
Oh, you're right. 1.10. Thank you. There we go. Let's see what happens. Okay, bingo. That's why it works. You do have to put in the right IP address, it turns out. Okay. So we have 5 bangs. Each of those is a successful ping. Notice that the router sent 5, whereas the workstation, when it pinged, it only sent 4. That's fine. It's just the way the different operating systems work. In this case, all 5 were successful. So now I can ping from the router to the workstation and from the workstation to the router. Okay. I would suggest, recommend that you folks do all that I've just done tonight on your own packet tracer with my scenario. And you can save it as it is or not, it doesn't really matter. It's up to you. But that way you have some initial interaction with packet tracer, routers, and workstations. And it's just a matter of knocking around with it. With practice, it'll all become second nature. Okay. Any questions? Now let's just do, I'm curious as to whether I saved it. I don't know that I saved the let's do a show run and see. I think I've got the host name and I've got the interface configuration, but let's look at a show start and see if I have the interface. No, so I haven't saved my configuration since I added the IP address and the no shutdown. So if I were to reload this router when it came back up, it would not have an IP address if I were to reload. Let's just demonstrate that. I'm going to do a reload. It says, do you want to save your configuration? I'm going to go no, so that I demonstrate this. Normally I would go, what's going on here? No. Proceed with reload. If I press enter, it will confirm it. Away I go. So now the router is coming back up. When it comes back up, it will not have the configuration. You notice that if you can see it, if you're doing this, you'll see that you're going to have boom, router there. So I press enter. Now it's router one. So I didn't save the changes I made to the interface, but I did save it when it had the host name. So it comes back up with the same host name. I go EN to go, that's for enable, to go into privilege exec, and I do a show run. And now I don't have all that information that I saved before, or that I created before. I didn't save it. I have the host name because I saved it after that, but I didn't save it after I changed the fast Ethernet information. Okay. So what I would need to do is re-enter that, which would be a bummer. Unless I'm getting paid $300 an hour, in which case I don't mind. Any questions on that? Okay. Somebody unmute.
One more time. How do you save for the? How did you? How could you save for fast Ethernet 00 to show?
Okay. So I haven't made any changes since I brought. I'm going to make a change. Okay.
Oh yeah, you made the change and then you said exit. You had to.
I'll show you. I'll do.
Okay.
No problem. I have to make a change to really demonstrate this. Config T. I'm going to set the host name to router 2 just for now, okay? Just to make a change. All right. See it now, it's router 2. I exit,
Yeah.
and then I'm going to go copy, run, start. Start config, yes, bingo. Do a show start.
Oh, but you showed this as this before. So for the fast Ethernet 00, that's all you do? Copy, run, start, or what?
Well, whatever copy, run, start changes, it saves the running configuration and any changes you've made to it.
Oh.
So when copy, run, start says copy the running configuration, which is in RAM, to the starter configuration, which is in NVRAM, non-volatile RAM. And when you do that, then your configuration that's in non-volatile RAM will be there when you reboot the router. So if I were to reboot this router or reload this router right now, it would come up with the host name as router 2 because that's what's in NVRAM.
Got it. Thank you.
Okay.
Yeah.
All right. So I think what would be good now, Armando, you might have done this enough to where you don't even need this practice, but I would think for Roger and Georgiana that it would be worth your while just to do this very simple exercise just to begin to get comfortable with the CLI. It's not a lot of commands, but hopefully you can do that simple thing. Bringing up the router. I would just change the host name if that's just want a little practice. Change the host name, save it, and reload. Or save the host name, give it an IP address, test with ping, and so forth. If you can just try and complete what we did tonight, if you can, don't wrestle with it too much if it's not clear. But if you can, that would be good little practice to cement in what we did. Okay.
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 Got it.
Yeah.
Well, at least you recorded it so I can take a second look.
Yes, I did record it. I can, but you know what we can do is let's just do it. Let me just do it a couple more times, okay? Or do it one more time and I'll show you, okay? So what I'm going to do is I'm going to wipe out the startup config. This is a command you'd want to know. Erase start. That's going to wipe out everything that I've saved. Okay, and I'm going to continue. Wow, I'm going to remove all the configuration of bingo. Okay, now if I reload, it's not going to come up with router 2. If we do a show start, there's no startup config, right? So erase start, wiped it out. To reload the router, it's reload. Proceed with reload, yes. And now it's going to reload. Now, here's a note. When it says this, would you like to enter the initial configuration dialog? The answer is always no. Okay? Just remember that. You do not want to get into that. Bingo. Now, I'm back at what mode? I'm at the user exec mode. How can I tell? Because the greater than sign, the prompt says it has the greater than sign. I'm going to go into the enable mode. To do that, I type enable and press enter. I'm now in the enable mode. I want to configure the host name. It's a global configuration command. I go config T, enter, and I'm now in the global config mode. Okay, I'm going to set the host name as router 1. Press enter, it changes instantly. I'm going to come out of the global config mode with exit. And I'm going to see that I have made that change in my running config, show run, enter. There's the configuration change, hostname router 1. Escape stops the output. I'm going to do a show start and see that I have not saved it there. So the command is copy, run, start, enter, and enter, and now it is. I do an up arrow, show start, and now it's in the startup config and the running config. So if I reload now, it'll come back up with router 1.
Got it. But there is no relation between router 1 and PC 1
No.
in the start. It's just the PC 1 you configured using that.
Yes.
Yeah.
When I configure PC1, it's like I took out a computer and I configured it. It has nothing to do with the router.
Yeah.
It's just the way the simulator presents them on the screen, but as far as the simulator is concerned, they're different devices. Just like if you had your router at home and you had your PC. Okay. Yeah, the only way that you can get good at the CLI is by practicing. That's the only way, okay? You could sit here and watch me enter commands, you know, it would eventually you might pick them up, but it's a lot slower way to learn. Believe me, what you want to do is get in, enter a few commands, and pretty soon, you know, it's really one of those things. You get to a certain point, it's like, oh, okay, I got it. Now it's second nature. It's easy. I remember when I had to make the transition over to Juniper. They do it differently, and at first it was like, oh my God, what the heck's going on here? But after a while, it's like, oh, okay, this is it. Bingo. Your brain sort of kicks in and you understand this new way of interacting and it becomes very comfortable. And eventually the CLI will become comfortable for you for Cisco as well. So, and then you can share that with family and friends around the dinner table if you want. Anyway, you might have mashed potatoes thrown at you soon, but hopefully not. Anyway, any further questions on that? Anybody want to practice any more on it, or?
I'm good.
Okay.
Good.
Okay, well then we'll wrap up for tonight, and I will see you folks Monday evening at 6 o'clock.
Thank you.
Thanks.
All right.
Thank you.
Thank you.
Have a good weekend.
You too.
Good
Have a good
week.
weekend.
Bye.
Bye.
Bye.